Okay, so just to give a recap on welfare, welfare has three components in it. The first component is consumer surplus. Okay, so consumer surplus was, suppose you have some demand function, and this is the price which consumers pay, and this is the quantity which consumers buy. So if these are your variables, then this area will represent your consumer surplus. Right? Then we had producer surplus. Go here. So if I want to calculate the producer surplus, then yeah, if this is the quantity and this is the marginal cost curve, which looks like this. Let's say this is my marginal cost curve. This is the price which suppliers get or producers get, and this is the quantity which gets supplied. Then this area, right? Yeah, this area. Okay, so this area, it's going to represent me the producer surplus. Okay. And finally, the third thing is your government surplus. So government surplus is just government taxes or government revenues, net government taxes or net government revenue. So government tax income minus government cost. So the important thing to remember is when you calculate consumer surplus, focus on the demand curve, the price which consumers pay, and the quantity. The area bounded between these curves will give you the consumer surplus. And when you're talking about the producer surplus, look at the marginal cost curve, the price which suppliers get, and the quantity which gets produced. The area between these curves is going to give you the producer surplus. So as long as you are clear about these two notions, you should not face any sort of problem in any situation which you are handling. And this is not just true for competitive market, by the way, although till now we have only done competitive market. This is not true only for competitive market. This is true for all sorts of market. Now let's move on to the second type of market which we want to discuss. Okay, first before that, okay, incidence of taxation. Incidence of taxation. This is an interesting topic. Incidence of taxation. So suppose a per unit tax of T is levied on a good with supply function S and demand function D. So this leads to a wedge between price felt by the consumers and the producers. All right, so I told you that if you have a per unit price of T, then price which consumers pay minus price which suppliers get is going to be differentiated by an amount of T, right? So suppose you have a 10% tax on some particular commodity. So if the producers are charging 100 rupees for that product, you are going to pay 110 rupees for that product. So the difference of 10 rupees is going in the pockets of the government. The question we are looking at is, whose pocket is this 10 rupees coming from? Now, everybody has this idea that tax always comes to the consumer. That's not really true, right? That's not really true, and we'll see now why. But why it's not true in a very basic sense is, suppose the government imposes a 10% tax on iPhones, let's say. Now, if iPhone, it's not imposing this tax on Android phones. Government is saying, I don't like iPhones. Government is saying, I am going to impose a 10% tax on just iPhones. So what happens in that case? Can Apple just increase the price of 10 by 10%? What will happen if it just increases prices by 10%? What will happen is that people will stop consuming the good by a huge margin. The sales will drop phenomenally in such a way that you would actually make very less profits. So it would be better for Apple to absorb some of this tax instead of passing it on completely to the consumer. The reason this is true is because Apple has a competitor. Okay, Apple products, that is iPhones particularly, have a competitor in the sense of Android phones. But let's say government imposes a 10% tax on fuel, let's say petrol. Okay, so petrol is a commodity in which if you increase taxes by 10%, all your suppliers can straight away increase the price by 10% because they know that whatever price they charge, people are still going to buy fuel. Okay, there are going to be very few people who are going to be like, okay, 10% increase, okay, so I'll stop taking the cab, I'll start using the metro. That fraction is very less. Okay, so it really depends on the elasticity of demand, how elastic the demand is. The demand for iPhones is pretty elastic on one hand. On the other hand, you have demand for uh, petrol or cooking oil or essential medicines like insulin. So if you impose taxes on insulin, everybody has to cough up. Nobody can be like, okay, it has gone up, I'll stop buying insulin, I'll stop buying that medicines. That doesn't happen. So this incidence of taxation is going to put that idea into some sort of a mathematical, it's going to give you a mathematical proof for that, that how this tax is going to be distributed, how it depends on the elasticity. Yeah. So we start off with some per unit tax T, which is being levied on some good with supply function S. So S is the supply function. Okay, and D is the demand function. Okay, so these are both functions of prices. Okay, so S of P, this is basically how much are the suppliers willing to supply if market price is P, and D is also D of P. This is how much demand there is in the market if price is P. So they are both functions of prices. So I know that the price which consumers pay minus price which suppliers get is going to be differentiated by this amount T. Now for market to clear, market clearing means quantity demanded must be equal to quantity supplied. So for market to clear, the demand of the consumers must be equal to the supply of the firms. So supply is a function of price which suppliers face, right? So let's say in the example I gave you, price of consumers is 110, price of suppliers is 100 because tax was, let's say, 10%, which was 10 rupees. So the quantity demanded at 110 must be equal to quantity supplied at 100 bucks. So whatever suppliers are willing to supply at 100 rupees must be equal to the quantity which is being demanded in the market for 110 rupees. So this is what this equation means. This is the market clearing condition. Now this 100 rupees can essentially be written as 110 minus 10. The reason I'm writing it like this is because the price which suppliers get is basically price which consumers pay minus the tax. Okay. So now if you just focus on these two parts, the entire equation is in terms of a single variable, that is PD, which is price which consumers pay. So I'm going to differentiate with respect to PD. Okay. So when I differentiate with respect to PD, I'm going to use the chain rule here. So dPD, demand at PD is equals to supply at PD. So differentiating with respect to PD gives me D demand at PD divided by dP. Okay. Now it's like PD minus T. PD minus T. Okay, so this is going to be equal to so this is supply as a function of PD minus T. So so this is going to be ds by dPd. into d of PD minus T by dPd. Right? This is my chain rule of differentiation. Now ds by dPd is just a differentiation of supply function with respect to price. So I can write it as SP. I'm writing this thing as SP. Differentiation of PD minus T by dPd is going to be 1 minus dt by dPd. Right? So, okay. Oh, sorry, I have to differentiate with respect to taxes. Sorry, I have to differentiate with respect to taxes. Okay. Wait, differentiate with respect to tax, not with respect to PD, because you're not changing PD, you're changing taxes. So suppose you are differentiating with respect to taxes. So when I'm differentiating with respect to taxes here, let me just get rid of all this. So yeah, I'm differentiating with respect to taxes. So by chain rule, D demand by dPd into dPd by dt. So this is chain rule. So I'm differentiating with respect to tax, but this is a function of PD, not a function of tax. So I differentiate it with respect to PD, and then I differentiate PD with respect to tax, right? And coming here, I'm going to differentiate supply function with respect to PD, and then I'm going to differentiate this interior thing with respect to tax. Now, differentiation of demand function with respect to PD is my dp function. What does it mean? Okay, so suppose your demand function is quantity demanded is equals to 10 minus p. So d of demand by dp is basically equal to -1, right? So I'm just going to differentiate this thing with respect to -1. So it really depends on what this demand function is. So what we are doing is a generic algebra. If I give you some mathematical equations, you can always apply it. But I want to derive a generic formula right now. So that's why this dp is just differentiation of my demand function with respect to price into dpd by dt. Okay, and this thing becomes sp into differentiation of pd minus t by dt. So this is going to be dpd by dt minus 1. Forget about this thing. Now dpd by dt is something, let's say, I am interested in. So what I get is dp into dpd by dt is equals to sp into dpd by dt minus sp. So this implies that sp is equals to sp minus dp into dpd by dt. So this gives me that dpd by dt is equals to sp upon sp minus dp. Okay, where this sp thing is basically differentiation of quantity supplied with respect to price, and this dp thing is differentiation of quantity demanded with respect to price. Okay, so let's say your quantity demanded function is this. Let's say your quantity supplied function is equal to tp. This implies that dqs by dp will be equal to 2. Okay, the important thing for you to understand is that for all normal goods, this value is going to be negative and this value is going to be positive. Okay, so dqd by dp is going to be positive because is going to be negative because as price increases, quantity demand is going to reduce. Whereas this thing is positive because as price increases, quantity supplied is going to increase. If price of any commodity increases, let's say in 2 years back, or 1.5 years back, the prices of masks, okay, face masks increased. So a lot of people started producing face masks and supplying face masks. So that's the idea. If prices increase, quantity supplied increases, whereas demand reduces. Obviously, this is a shock case, so keeping everything else constant doesn't work here. So that's why in case of masks, we saw a shift in the supply, in the demand curve itself. So that's why that's a different case. But keeping everything else constant, if prices increase, quantity demanded is going to fall. So this is SP is going to be a positive thing, whereas DP is going to be a negative thing. So SP, like in this case, is 2, and DP, like in this case, is -1. So if we use those numbers, we see that dPd by dt is actually equal to 2 upon 2 minus -1, which is 2/3. Now, what is dPd by dt? dPd by dt is the change in consumer's price when taxes go up by 1 rupee. Okay, so this is change in consumer price when taxes go up by rupee 1. So if you increase tax by 1 rupee, the consumer price only increases by 2/3 rupees. So consumers are paying 2/3 rupees more because they have to pay these taxes. But then the question is, the government takes 1 rupee. The consumers are only giving 2/3. So who's giving the remaining 1/3 rupees? So that comes from the suppliers. So for that, you can just use the equation that PD minus PS must be equal to T. And then I totally differentiate this equation with respect to T. Okay, so basically I'm going to differentiate this thing with respect to T. So dPd, so I can write this as PD minus PS minus T is equals to 0. And then you differentiate with respect to T. So dPd by dt minus dPs by dt minus T is equals to 0, which implies dPs by dt, sorry, -1 equals to 0. So dPs by dt is equals to dPd by dt -1. So in this case, where we saw that dPd by dt was 2/3, we see that dPs by dt becomes equal to 2/3 minus 1. So that is -1/3. So suppliers are getting 1/3 rupees less. So suppliers are getting 1/3 less than what they were initially getting. And consumers are paying 2/3 more. So in a way, consumers are paying 2/3 rupees from their pocket to the government, and suppliers are paying 1/3 rupees out of their pocket to the government. Okay, so it's not very simplistic here that if you increase taxes, it is always going to be the consumer who's going to pay it. Right? So it's not going to be that straightforward. Now, coming back to these equations, that dPd by dt is equals to SP upon SP minus dP. Okay, by the way, everybody understands now. I hope all of you understand how this 2/3 is coming from the consumers and 1/3 is coming from the suppliers. It really depends on the supply and demand functions. Okay, so it really depended on these functions which I have assumed. You take some other functions, you get a different result. So coming back, this dPd by dt is SP upon SP minus dP. Okay. So SP is basically D quantity supplied by DP upon D quantity supplied by DP minus D quantity demanded by DP. Okay. Now I can multiply this by P by Q, this by P by Q, and this by P by Q. So this thing, okay, now remember this quantity Q is at market clearing level. This quantity Q is basically equal to quantity supplied and equal to quantity demanded. So here I'll substitute this Q with QS. Here I'll call this Q as QS, and here I'll call this Q as QT. The reason I'm doing this is that now this numerator is basically elasticity of supply. And this thing becomes elasticity of demand. So what I have in the end is dPd by dt is equals to elasticity of supply upon elasticity of supply minus elasticity of demand. Okay. And if I want to write it in modulus terms, since you know that elasticity of supply is positive and elasticity of demand is negative. So if you want to write it in modulus terms, this is going to be mod elasticity of supply upon mod elasticity of supply minus mod elasticity of, plus mod elasticity of demand. Okay. So this clearly tells me that it's a fraction which is less than equal to 1. It will be equal to 1 only when mod ED is equals to 0. Mod ED equals to 0 means demand is perfectly inelastic. So when demand is perfectly inelastic, in that case, what happens is that dPd by dt becomes equal to 1. So when demand is perfectly inelastic, what's happening is if you raise taxes by 1 rupee, the price which consumers pay goes up by 1. Okay, so the entire burden is shifted on the consumer. So if you might remember, at the fag end of the second wave, the government was being cornered about imposing taxes on COVID medicines. So initially, Nirmala Sitharaman gave all kinds of reasons why it's there, that she made some technical terms, but ultimately the government had to back down. The government had to reduce the taxes, because the idea is that if you impose any taxes, since it's a completely inelastic demand, if you are suffering from COVID or any disease, any disease which can be terminal, you have to buy the medicine. There is no option there. So the entire burden of taxation will be passed on to the consumer. And that's why when demand is perfectly inelastic, the consumers feel the pinch. On the other hand, dPs by dt will be equal to Ed upon Es minus Ed. Okay, which in magnitude terms would be negative of mod Ed upon mod Ed plus mod Es. So mod Es plus mod Ed. The reason this negative comes is because supplier's price will reduce if there's taxation. It cannot be that tumne tax lagaya and suppliers start getting more money. Taxation is good for neither the consumer nor the producer. Nobody likes taxes, period. Okay, it's not that if taxes come, the companies are immune to it or they enjoy taxes. Nobody enjoys taxes. We still have to pay it. It's the ransom we give to the government for the government to protect us. That's the idea. Okay, so if you pay taxes, the government can maintain law and order. If you stop paying taxes, Pakistan will come. That's the idea. Okay, Pakistan will invade, China will invade, everybody will invade. So you pay taxes in exchange for law and order and other services which the government provides to you in whatever capacity they can. But that's the idea. Nobody likes taxes. The bottom line is consumers and suppliers both get affected by taxation. So in what case would this be equal to 1? Magnitude wise, or in realistic terms, when would this be equal to -1? What here needs to be 0 for this value to be equal to -1?
So elasticity of supply.
Yeah, what about elasticity of supply?
It needs to be 0.
It needs to be 0. It means that supply should be perfectly supply should be perfectly inelastic. It means that I'm willing to supply this much quantity no matter what. I want to supply this much quantity. But forget that. Okay, forget that. Yeah, that is correct. When ES is 0, this will happen. Think in terms of ED. What should be happening to ED? Think in terms of limits, by the way. Just to give you a clue, think in terms of limits. What should be the limits on ED for this to be equal to -1?
So it approaches to 1.
Okay, when ED is 1, this becomes -1 upon mod ES plus 1, which is not equal to -1. Okay, I'm saying forget this. Don't hold this thing right now. That is correct. I'm thinking I want to look at demand. What happens to demand for this thing to be -1? So not 1, definitely not 1. Think something else. What should be ED? For a given value of ES, ES is some fixed value, some constant. Okay, so for a fixed given value of ES, what should be the limiting value of ED for this fraction to approach -1? Okay, what is limit ED tending to tending to infinity? What will be this value limit ED tending to infinity? Come on, we did limits.
Yes, sir, -1.
Okay, limit x tending to infinity minus x upon k plus x. Okay, what would this value be? This would be -1, right?
Yes, sir.
You can apply L'Hopital if you want. For all you care, this is infinite by infinite format right now. So it is infinity by infinity format. So you can apply L'Hopital, right? So it gives you -1. So the idea is when ED tends to infinity, that's when this thing becomes -1. What is ED tending to infinity? ED tending to infinity means that demand is perfectly elastic. Demand being perfectly elastic means तुमने ₹1 भी बढ़ा दिया तो I'll just stop buying your product. I'm buying your product till you're selling at 10 rupees, let's say, till at 100 rupees. Okay, so suppose there's a domestic producer who's supplying something at 100 rupees and a foreign producer, an importer, somebody who's importing something, who's also supplying this at 100 rupees. Suppose there's a tax imposed on the importers. Okay, if this tax is for 10%, let's say, the supplier has to bear the entire 10%, because if he increases the price by even 1 rupee, people will stop buying from the importer. People will simply buy from the domestic firm. Okay, so that's the idea. That's the idea. So if demand is perfectly elastic, that is when ED tends to infinity, in that case, The suppliers, they have no power. They have to bear the brunt of the taxation. But on the other hand, when demand is perfectly inelastic, that is when consumers have no power, you have to buy it whatever I sell it at. Let's say cooking oil, medicines, petroleum, CNG, LPG. These are all electricity. These are mostly things which you consider as inelastic. Perfectly elastic, in my opinion, perfectly inelastic would be medicines. Nothing comes close to medicines for critical illnesses. When you talk about things which are perfectly inelastic, everything else is a little elasticity will be there. You won't see ED equals to zero. ED equals to zero would only happen in case of medicines. So in case of medicines, you see this ED equals to zero. In that case, the suppliers have the complete power. But in case of ED tending to infinity, it is the consumers who have all the power. All right. So it's a very interesting thing to understand. I like this because a lot of times we feel that if taxes go up, it is always going to be the consumers who are going to suffer because of it. But if you look at the root of these issues, you will see that when GST was being imposed, there were a lot of industries, particularly textiles, where it was not the consumers, but the producers who were protesting against GST. The textile manufacturers, particularly in Gujarat, they're protesting against GST on cotton because they were saying that if you impose GST on cotton, people will stop buying cotton. We cannot pass it on to the consumers. People will start buying other goods like jeans. So that will be a loss for the producers. So it's not always straightforward that if there's taxation, the consumers will always pay it. Okay. Interesting topic. Let's start the next topic, that is monopoly. So monopoly is a single firm, okay, it serves an entire market. A single firm faces market demand curve for its output. Using its knowledge of demand curve, the monopoly makes a decision on how much to produce. So unlike the perfectly competitive firm's output decision, which has no effect on market price, the monopoly's output decision will in fact determine the goods price. So in perfect competition, we assume that the firms are price taking. That is, firms, they just they cannot have any say in the price. The price is given in the market, you have to play by that price. In the case of monopoly, on the other hand, by choosing how much you decide to supply, the prices will fluctuate. You supply more, prices will drop. You supply less, prices will go up. Okay. Why monopolies exist is a different chapter altogether. We're not going to concern about it. There could be a lot of reasons. Mostly it's like barriers to entry, like the government set monopolies. For example, in government monopolies, you have railways, a good example. Other could be technology. So for example, Google. So Google in search engines can be considered a monopoly. The other could be monopolies because of patents. So that is in field of medicines. So if you devise a product which nobody else has devised, you get some monopoly rights over. So all those things are normative issues. We don't want to deal into why monopolies exist, how they exist. Our story starts from a monopoly existing. Okay, so some monopoly M exists. So now what happens? What is the story after that? So suppose these are the curves for a monopoly. This is the marginal cost curve. Okay, this is the average cost curve. This is the demand curve for the market, and this is the corresponding marginal revenue curve. So how do you get the marginal revenue curve from the demand curve? So suppose demand is quantity equals to 10 minus P. So revenue for any quantity would be P into Q. Okay, so the inverse demand function is, let's say, price equals to 10 minus Q. So the revenue becomes price into quantity, which is 10 minus Q into Q. So marginal revenue becomes dR by dQ. So that is equal to 10 minus 2q, right? So if 10 minus q was my demand function, then 10 minus 2q is my marginal revenue function. Okay. Finding marginal cost, average cost, we have done that a lot, right? So we have done that a lot in chapter 2, how to find marginal cost and average cost. So we'll not, like I told you, chapter 2 is all about finding the cost function. After that, you'll always be given the cost function. Nobody is going to ask you find the cost function. Find the cost function types of question come once in 3 years. In remaining all the questions, they'll just directly give you the cost function. You don't have to worry about it. So this is the marginal cost function, average cost function, all that is here, fine. Now coming to the profit function of a monopoly, the profit function is revenue minus cost. When I differentiate with respect to quantity, I get dr by dq, which is my marginal revenue, minus dc by dq, which is my marginal cost. So this is my d pi by dq. So at profit maximization, d pi by dq must be equal to 0, which implies that mr must be equal to mc. So marginal revenue must be equal to marginal cost. So you see, this is my marginal revenue curve. This is my marginal cost curve. The two intersect at this point. So that is going to give me the quantity which is going to be supplied here. So the quantity supplied is going to be given by this intersection. So this is the quantity which maximizes the profit. So as a quick example, consider this as my marginal revenue curve. Suppose the marginal cost is equal to 2q, is equals to 2q. So how do I find my profit maximizing quantity? So it's just going to be equal to mr equals to mc. So that is 10 minus 2q must be equal to 2q, which implies q must be equal to 10 by 4. So that is 2.5. So 2.5 is the profit maximizing quantity. Now the question is, what should be the price at which you sell this 2.5 units? So that will be given by this function. So this is quantity monopoly. Price monopoly is going to be equal to 10 minus 2.5. So that is equal to 7.5. So that happens when this quantity intersects the demand curve. So that is this quantity. So this is my price of the monopoly. Right? Now, finally, coming to profit, profit is equals to price minus average cost into quantity. Right? Very simplistically, profit is price minus average cost into the quantity. So this is price minus average cost is profit per unit, and into Q is going to give you the total profit. So price minus average cost. So this is my average cost at this level of quantity. So price minus average cost into quantity is this rectangular area. So this is your profit. Okay. All right. So graphically, this is the entire setup of a monopoly. So let me give you a different setting. So a quick example for you guys. So suppose that the demand function is quantity demanded is equals to 100 minus 2p, and marginal cost is equals to 5. So find quantity supplied by the monopolist, price of the monopolist, and profit of the monopolist. So what are going to be these values? So you have price. So quantity equals to 100 minus 2p. So this implies price must be equal to 50 minus q by 2. Revenue is equals to price into quantity. So this is 50 minus q by 2 into q. So marginal revenue must be equal to dr by dq. So that is, so this is basically 50q minus q square by 2. So this should be 50 minus q. This correct? I don't know how you got whatever you guys got. So marginal revenue must be equal to marginal cost, which is 5. So 50 minus q must be equal to 5, which means q must be equal to 45. So this is my monopolist quantity. Is this right? So where did you guys make a mistake? I don't understand. Can anybody, I mean, you guys are making a mistake. I'm here to help you. You guys are paying me to help you. If you don't use it, I mean, I don't know. It's your loss. Really, I mean, if you can't even tell me where you guys made a mistake, I can't really help you. Anyway, fine. Price of monopolist becomes equal to 50 minus q by 2. So that is 50 minus 22.5. So that is 27.5. And profit of monopolist will be equal to just PM minus MC into QM. So that is 22.5 square, whatever that value is. All right, fine. I mean, this is the easiest question which they can ask you probably related to monopolist. I hope you guys know now whatever mistake you did and you guys won't repeat it in the exam, obviously. The actual question would not be so easy. Coming back, marginal revenue is equals to marginal cost. So I want a relationship between, I have a very nice relationship between elasticity and marginal revenue, which I had from a previous situation, that marginal revenue, so revenue is equals to P into Q. When I differentiate with respect to Q, I get marginal revenue must be equal to P plus Q times dP by dQ. Right? Because price and quantity are no longer independent. Price and quantities are dependent in case of a monopolist. So I can take this P common here. So I can take this P common, 1 plus Q by P times dP by dQ, right? Now remember that the elasticity of demand is dQ by dP into P by Q. So this thing which I have here is basically 1 by elasticity of demand. So marginal revenue essentially becomes price into 1 plus 1 by elasticity of demand. And in case of a monopolist, marginal revenue must be equal to marginal cost. So what I have is that marginal cost must be equal to price into 1 plus 1 by P. Okay, so what I have is that marginal cost must be equal to price into 1 plus 1 by P. So this implies that MC by P is equals to 1 plus 1 by E. So this implies that MC by P minus 1 should be equal to 1 by E, which implies that MC minus P by P, oh no, wait. MC by P must be equal to 1 plus E by E. So this implies P by MC must be equal to E upon 1 plus E. And then I subtract 1 from both sides. So P by MC minus 1 must be equal to E upon 1 plus E minus 1. So what that gives me is P minus MC upon MC must be equal to minus 1 upon, okay, wait, 1 plus E by E. MC by P is 1 plus 1 by E. So 1 plus E by 1, P minus MC by MC is equals to, yeah, minus 1 by 1 plus E. Yeah, fine. Now this thing is what you call as a markup. And this is a relationship on elasticity. Now this relationship is pretty important because it relates elasticity, marginal cost, and prices. So in some lower level exams, not DAC ISA particularly, but some other exams, maybe JNU, IGIDR, what they can give you is they can give you a monopolist's marginal cost, price, and ask you elasticity. Basically, this is a relationship between three terms. So they can give you any two of them and ask you the third. So you should be able to derive this. Obviously, if you can remember it, great. If you can't, then you can derive it in exam. Another way to do this is just starting from here. You can do a minus 1 here. Okay, so you can alternatively do minus 1 here. So this will just give you MC minus P by P is equals to 1 by E. Okay, so this is another relationship. Both these relationships can be derived easily if you remember that marginal revenue equals to marginal cost, and you remember this relationship that marginal revenue is equals to price into 1 plus 1 by E. Okay, this thing holds for all firms, whereas these two things, they only hold for a monopolist. Okay, so relationship between marginal revenue and price elasticity holds for all firms, but the relationship between marginal cost, price, and elasticity, it holds only for a monopolist, because for a monopolist, marginal revenue is marginal cost. Okay, we have no supply curve for a monopolist. There is no supply curve which exists for a monopolist. Okay, so let's do this problem. So suppose a monopolist has this demand function and this is the cost function. So find the profit maximizing quantity level. All right, fine. Let's look at this question. Q equals to 2000 minus 20p. Which implies, sorry, minus 20p, which implies price must be equal to 2000 minus q by 20, which is 100 minus q by 20. Okay, so that's my price. Now cost is this. So let's find the marginal revenue. So revenue is equals to price into quantity. So that is 100 minus Q by 20 into Q. So that is 100 Q minus Q square by 20, which implies marginal revenue equals to 100 minus Q by 10. Now from here, I know that marginal cost is equals to, this is 1 by 20, right? 0.05 is 1 by 20. So marginal cost is 1 by 20 into 2Q. So that is Q by 10. So marginal revenue must be equal to marginal cost. So 100 minus Q by 10 must be equal to Q by 10, which implies Q by 5 or 2Q by 10 must be equal to 100, which implies Q monopolist must be equal to 500. Okay, so that's my monopolist quantity, Q monopolist. So once you know the quantity, everything else follows, right? So you don't need to worry about the next steps. The only important thing is finding quantity. Now, welfare losses. Now, in comparison with the competitive market, a monopolist level of production reduces the net social surplus. So you can look at this in the diagram here. So if I zoom into this diagram, so to this one here, this one. Okay, yeah. Okay, so if I zoom into this diagram here, you see that this is the marginal cost curve. This is the demand curve. Now, had this been a perfect competition solves the intersection of marginal cost and the demand curves. Right, so this would have been the quantity produced in perfect competition. This would have been the price in perfect competition, and the total surplus in perfect competition would have been this much. Right, so this would have been the total surplus in perfect competition. Now, in case of monopolist, what's happening? So in perfect competition, my total surplus would have been this much, basically. This would have been my perfect competition level of welfare. Now, in case of monopolist, what happens is that you're producing this much quantity, the quantity where marginal revenue intersects with marginal cost. So you're producing a lower quantity. Price is higher. Okay, price is higher. And the total surplus now is just this much. This is the total surplus, total welfare in case of a monopoly. The remaining portion, which is this region, is the loss in social surplus because your market is run by a monopolist as opposed to a perfectly competitive setup. So this is what you call as the deadweight loss of a monopolist. Okay, so this is what you call as the deadweight loss of monopoly. All right, so how do I find the deadweight loss of a monopoly? So I'll do a simple question, then I'll pass on a more difficult one to you guys. So that's how it works, right? So so let price is equals to what was it, 10 minus Q, and marginal cost is equals to Q, right? So find social surplus for perfect competition and social surplus for a monopoly. So if I find the two social surpluses, I'll get the difference as the yeah, the difference would be the deadweight loss of the monopolist, right? So social surplus of perfect competition. So this is my demand function 10 minus Q. This is my marginal cost function Q. Now, my social surplus in case of perfect computation. So this value is 10. This value is 5. Quantity of perfect computation is 5. So this area of this triangle will be half base into height. So that will be half into 10 into 10. So that is 25. Now I already know that the marginal revenue in this case is 10 minus 2q, which becomes equal to q, which implies quantity monopolist becomes equal to 10 by 3. So the monopolist quantity is going to be lower. It's going to be 10 by 3. Q monopolist is equals to 10 by 3. Okay. So this is my Q monopolist. So I want this area. This will be the social surplus of a monopolist. Okay. So how do I find this area? I know the larger triangle. Right. So this, after this point, it's a little bit of geometry. I know this triangle. If I can subtract the area of this smaller triangle from it, the remaining thing becomes the social surplus of the monopolist. So how do I find this smaller area? So I know that this distance is 5 minus 10 by 3. Right? So 5 minus 10 by 3 is 5 by 3. So this gives me the height of the triangle. All I need is now this base of the triangle. What is this value equal to? This is basically a monopolist price PM.
So 20 by 3.
Yeah, so it's going to be 10 minus, this is the demand function. So price equals to 10 minus quantity. So quantity is 10 by 3. So 10 minus 10 by 3 is 20 by 3. Now this is marginal cost at this quantity. So what is the marginal cost of the monopolist? At
10
quantity
by 3.
10 by 3. 10 by 3. Very good. Because marginal cost function is equals to quantity. So if quantity is 10 by 3, marginal cost is 10 by 3. So this value is 10 by 3. This value is 20 by 3. So what is going to be this height?
10 by 3.
10 by 3. It's just the difference. So the height is 10 by 3. This width is 5 by 3. So this smaller triangular area is going to be half, which is basically my deadweight loss, is going to be half into 10 by 3 into 5 by 3. So that is 25 by 9. Okay. So now social surplus of perfect competition was 25. Deadweight loss of monopoly.
Excuse me, sir.
Yeah.
So shouldn't that area be 15 by 2? It's half into 10 into 5.
So I'm cancelling this 2 with this
Instead of
10.
25. SS
Yes.
under perfect competition should be 12 by 5.
Okay.
12 by 2. 15 by 2.
Oh, sorry. Okay, did I make a mistake here? So in perfect competition, my quantity was 5. Right? So this region was 5. This was 10. No, in perfect competition, the quantity is 5, right? If I draw this figure again, this entire triangle is my perfect competition, right? Quantity gives me this height. And the base is this entire thing, which is 10. Right? So the area is half into base into height. So half into 10 into 5. So that is 25. Is this clear?
Yes, sir, because you had written half into 10 into 10, so that's why I got confused.
Have I written that? Oh, sorry. Half into 10 into 5. Yeah. So this is 25. So coming back with these things, I know social surplus of a monopolist will be equal to 25 minus 25 by 9. So 8 by 9 times of 25. So that is 200 by 9. So this is how you can find the social surplus of a monopolist. So let me open this solution for you so you can refer to it, and then your job is to find the welfare for this case. Oh, that's 6. Yeah. So find the welfare for this case. This example which we just did. So had this been a perfectly competitive firm, what would have been the social surplus, and what is the social surplus now that it is a monopoly? Okay, so this is the problem. This is the example we did, which I am giving to you the solution as a reference point, how you can do it. But the main question that you're tackling now is this one. Okay, so now I have this marginal cost function, which is Q by 10. So I can just plot it here. This is marginal cost, which is Q by 10. And then this was basically the inverse demand was P equals to 100 minus Q by 20. So this is 100 minus Q by 20, right? So quantity of perfect competition would be given by marginal cost equals to the demand. So 100 minus Q by 20, marginal cost equals to price. So 100 minus Q by 20 is price. So price must be equal to marginal cost Q by 10. So this implies that 100 must be equal to Q by 20 plus Q by 10. So that is 3Q by 20. So quantity of perfect competition must be equal to 2000 by 3. And price of perfect competition is equals to QC by 10. So that is equal to, yeah, because price equals to marginal cost. Marginal cost is Q by 10. So that is 200 by 3. So this is 200 by 3, which is PC. Now this area is obviously 100, right? So because that's the price when quantity is 0. When price for quantity is 0. So I know that price equals to 100 minus Q by 20. So this is 100. So this entire area is going to be this distance, which is 2000 by 3 into 100. So social surplus for perfect competition is going to be 100 into 2000 by 3. So that is 2 followed by a lot of zeros divided by 3. Okay. Now what happens in case of perfect competition? In case of monopolist. So in a monopolist case, I know that quantity is 500. I found that out. Quantity monopolist is 500 and price monopolist was equal to yeah, so if you put 500 as quantity here, then what should be the price? So price equals to 100 minus Q by 20. 100 minus Q was 500 by 20. So that is 75. Okay, so this point is 75. This is 50. Okay, and this distance is basically difference between 2000 by 3 and 500. A distance between 2000 by 3 and 500. So if I want to calculate this smaller triangle and call this as, let's say, delta, this area is delta, then my delta is basically equal to 2000 by 3 minus 500 into this point is 70, 50, 75. So the difference is 25. We can write it as 75 minus 50. So this is 500 by 3 into 25. So that's what 12500 by 3. Okay, so that's deadweight loss. And finally, social surplus for a monopolist is going to be social surplus for perfect competition minus my deadweight loss. So you can do the subtraction. What do we get? I don't think it will be 14,000 something. As you said, it should be something different. I feel it would be a little different. Yeah, in any case. So that's how you do a problem like this if it comes. So that's how you can find the deadweight loss of a monopolist. Okay. Okay, this is an example which I'm giving you as homework. Let's discuss this in the next class. Do remind me to discuss this. It's a very nice one, but I'll only discuss it once you attempt it. Okay, spend some time with it. Draw some graphs. Do something about it. Don't be like, okay, man, I looked at it, I couldn't do it, so I'll ask you. Take some time with it. Okay, just give me a second. Okay, fine. So next, now that I know how to deal with the monopoly, I want to look at the new topic, which is price discrimination. So what's in price discrimination? So in price discrimination, there's basically, I say that a monopolist, he can discriminate between different sections of the market depending on their paying capacities. So suppose a monopolist is somebody who knows exactly how much each person is willing to pay for the commodity. Suppose I'm a monopolist for giving out vaccines for COVID. So I can basically, if Ambani comes for this vaccine for COVID, I can charge him ₹1 billion. I can charge him whatever I want because he's a guy who's really scared. So he has a lot of money and I know that his willingness to pay for his life is too high. So I can basically extract a huge amount from him. Okay. So such a discrimination is called a first degree price discrimination. Okay, first degree price discrimination is when you basically take the entire paying capacity of every consumer as the price. So you charge every person who's consuming at the level of his paying capacity. So that's your first degree price discrimination. So how does that work? So first degree price discrimination. So if each buyer can be separately identified by a monopolist, then it may be possible to charge each the maximum price he or she would willingly pay for the good. Right? So maximum price he or she would willingly pay for the good. So that's my first degree price discrimination. So in first degree price discrimination, what happens is that the entire consumer surplus is absorbed. What is the consumer surplus for any consumer I? So consider any consumer I, CI is any consumer, or let's say XI is any consumer. So the surplus of XI is equals to basically the paying capacity of this consumer, which is, let's say, his willingness to pay for customer I, minus the actual price that he pays, PI. So suppose I like to buy an ice cream, and the ice cream, the willingness to pay for that ice cream, that is the amount of monetary utility that I get. So if I convert my utility in monetary terms, then that would be my maximum money which I'm willing to pay for that particular ice cream. So suppose my willingness to pay for an ice cream is 10 rupees, of let's say 50 rupees. Okay, let's say if I am willing to pay 50 rupees for an ice cream. The price of the ice cream is 25. Then the surplus in monetary terms which I have from consuming this ice cream is 25 rupees. But if the ice cream vendor knew that I get a benefit of 25 rupees, 50 rupees from consuming this ice cream, that is the maximum I'm willing to pay for this ice cream is 50 rupees, then he will charge me exactly 50 rupees. And then what happens is my surplus becomes zero. Now the surplus, the entire consumer surplus is basically summation of consumer surpluses of all the consumers in the market, I belonging to the entire market, M. So summation of all the consumer surpluses of different individual agents gives me the total consumer surplus of the market. Now in first degree price discrimination, each of these consumer surpluses is zero. So the entire consumer surplus becomes zero. So if you ignore government surplus, then I know that social surplus is equals to producer surplus plus consumer surplus. In first degree price discrimination, consumer surplus is zero. So basically I have that social surplus is equal to producer surplus. Now, suppose this is my demand curve, this is my marginal cost curve, and this is my marginal revenue curve. At what point should the quantity be supplied? Point 1 and point 2, if the aim is to maximize social surplus. Which quantity, 1 or 2, maximizes social surplus? Guys, this is a very easy one. What quantity maximizes social surplus? 1 or 2? This is my marginal cost curve.
So 2.
2. Very good. 2. Because you see, that's a perfect competition level of production. Okay, social surplus is maximized at perfect competition level. This is the maximum possible social surplus. Okay. Now, social surplus in first degree price discrimination is basically producer surplus. So what is the aim of the monopolist? The aim of the monopolist is to maximize producer surplus. The monopolist aim is to maximize social surplus. Maximize producer surplus. Right. But in this case, producer surplus and social surplus are the same. So maximizing one automatically maximizes the other. So in first degree price discrimination, the solution which maximizes, the quantity which maximizes producer surplus is the same that maximizes social surplus, because the consumer surplus is entirely rendered zero. So he will in fact produce a quantity which is equal to the competitive level of quantity. The quantity which will be supplied to the market will be the competitive level of quantity. Okay, so without discrimination, he was supplying the market a QM level of quantity, but with discrimination, he's going to supply more to the market, right? But obviously, he supplies more to the market, yet the prices, it's not really in the interest of the government, right? So if you think about it, if we allow for first degree price discrimination in the vaccine market, right, what would happen? What would happen is that there would be more production. If firms had a complete free hand as to कि कितना supply कर, like what you want to charge, if they had a complete free hand as to what they want to charge, then you would have more production. Simply, you see, QC is greater than QM here. QC is greater than QM. So if firms could do this first degree price discrimination, they would definitely produce more quantity. But that is something we don't allow because of ethical reasons. There are a bunch of other reasons. You don't want people to basically pay so much. If you keep the vaccine price as, let's say, 1 lakh rupees, people are not going to get vaccinated. People will stay away from vaccination. The disease will keep spreading. It will keep killing, and all those things will happen. So obviously not a good idea. But the bottom line is that in first degree price discrimination, the quantity supplied is going to be equal to the quantity which would be supplied in a perfectly competitive market. Right. So let's go back to the frisbee market as before, but let's assume that the monopolist can do first degree price discrimination now. So this was the monopolist example. I have actually copied it, I think, so I can paste it here. Yeah, good. So in this example, let's say in the market for frisbees, the monopolist can do first degree price discrimination. So this is my demand curve, sorry, the marginal cost curve, Q by 10. This is my demand curve, which is 100 minus Q by 20. So the quantity supplied by a monopolist will be equal to the intersection point, which we calculated in the previous example as 2000 by 3. So this will be the quantity supplied. Whereas without discrimination, the monopolist was only supplying 500 quantity. And this was the monopolist price. In first degree price discrimination, there's no price as such, because different consumers are being charged different prices. So there's no talk about price, that what's going to be the price here. But this was the price of the monopolist in first degree, in the previous case, which was 75. Right, it was 75 price of monopolist. Yeah. All right, fine. So that is first degree price discrimination. So remember, in first degree price discrimination, just find the competitive market outcome, and that's going to be the quantity which will be supplied to the market. It's very straightforward. Second degree price discrimination we are not going to do because it's a little more technical. I used to do it in the past, but it's not really worth doing it. They are not going to ask questions about it. So let's move to third degree price discrimination. What happens in third degree price discrimination is Now the monopolist is present in two different markets. So suppose this is market 1 and this is market 2. The demand functions are different in the two markets. So what he can do is he can charge different prices in the two markets so as to maximize the total so as to maximize the total profit, right? Now in this case, what happens is, so remember the case of a firm with multiple plants. We did this in second chapter, firm with multiple plants. So if a firm had two plants, 1 and 2, he would choose Q1 and Q2 in such a way. What was the relationship which they gave us Q1 and Q2? What was the deciding criteria between Q1 and Q2? How would he decide? What was the important relationship we studied in second chapter? No revision? Any guess? I can't wait forever for you guys. If you want to make a guess, now is the time. There are no negative marks to guessing. Anyway, marginal cost at Q1 must be equal to marginal cost at Q2. Do you guys remember that? Does anybody remember that? No. Okay, fine.
Yes, sir.
All right, fine. Thanks a lot. I mean, we spent quite a lot of time discussing this. So yeah, this was the result when firms had multiple plants. Now, a firm has multiple markets. So when a firm has multiple markets, what would happen is that the firm would equate marginal revenue in the two markets. The firm will divide a quantity, the total quantity supplied in such a way in Q1 and Q2 that the marginal revenues in the two markets becomes equal. So that's how a firm is going to spread out in two markets. So I know that marginal revenue in market 1 is equals to P1 into 1 plus 1 by E1. Marginal revenue in plant 2 is equals to P2 into 1 plus 1 by E2. So this implies P1 by P2 is equals to 1 plus 1 by E2 upon 1 plus 1 by E1. So this is a crucial relationship between P1, P2 and E1, E2. Okay. So that's a nice relationship between prices and elasticity, which maybe sometime they ask you, okay, they can ask you this relationship between prices and elasticity. So let's do this numerical problem. So price is 24 minus Q in market 1. Price is 24 minus Q by 2 in market 2. Marginal cost is 6, right? So let me add this page here. So marginal cost is equals to 6. Price in market 1 is 24 minus Q1. Price in market 2 is equals to 12 minus Q2 by 2. So these are the prices. Now you have to find MR1 equals to MR2 and how much is he going to sell in the two markets. So the relationship of selling is going to be MR1 is equals to MR2 is equals to MC. Okay. MR1 equals to MR2 equals to MC. So quickly give me MR1, MR2 equations and equate it to MC, and which will give you Q1 and Q2. Okay, so quickly find MR1 and MR2. Fine. So let's do this. Marginal revenue. So revenue from market 1 is equals to P1 into Q1. So P1 is already given to me. So 24 minus Q1 into Q1, which implies MR1 is just differentiating with respect to Q1. So that should be equal to 24 minus 2Q1. Now this should be equal to marginal cost. So marginal cost is equals to 6. So this gives me Q1 is equals to 24 minus 6 by 2. So that is equal to what? 18 by 2. So that is 9. Right? Revenue from market 2 is equals to P2 into Q2. So that is equals to 12 minus Q2 by 2 into Q2, which implies marginal revenue from market 2 will be equal to 12 minus Q2, which should be equal to 6, right? Marginal revenue equals to marginal cost, which implies Q2 must be equal to 12 minus 6. So that is equal to 6. Okay, so that is your yeah, so that's your answer. Okay, so it's very simple. Okay, it's very straightforward. Now suppose the firm is monopolist in first market. I'm doing a deviation of this question. Suppose he's monopolist in first market, but in the second market he is a perfectly competitive guy with price equals to 10. The price in second market is straight up 10, no changes. So in that case, what would be the quantities supplied in the two markets? So right now P1 is 24 minus Q1. In market 1, this guy is a monopolist. But in market 2, he's competing with other firms. So price in market 2 is straight up 10. So what's going to be the relationship of Q1 and Q2? In this case, I want you to find Q1 and Q2. Remember, everything is hidden in this one equation. Oh, sorry, I forgot to change this. Marginal cost is capital Q, by the way. Sorry. Yeah, marginal cost is capital Q. Sorry. Yeah. Marginal cost is capital Q. P1 is 24 minus Q1 and P2 is 10.
So he will produce up to Q1 equaling 14.
And Q2?
So Q2 would be Q by 10.
No, capital Q2, I need a number. You cannot give me one variable in terms of other variables. I need a final number like I did here, 9 and 6.
So it would be 10.
Q2 is 10. So what about Q1? So what I'm saying is that marginal cost is equals to Q, capital Q, which is basically Q1 plus Q2. Inverse demand in market 1 is 24 minus Q1. And in second market, price is a fixed variable, fixed value 10. So in this case, what's going to be the answer? Let me erase everything here. This was NC equals to.
So 14 by 3 is Q1.
Okay. And Q2?
So just 2.
Okay.
Q2 is 10.
Okay. All right, fine. So let's look at this situation. So first of all, MR1, as in the previous case, was what? What was MR1? 24 minus 2Q1. If I equate it to MR2, now MR2 is just P2, which is 10, right? Because revenue in market 2 is equals to 10 times Q2, right? So if I differentiate, I get MR2 equals to 10. So I equate it to 10. So this gives me Q1 must be equal to 14 by 2, which is 7. So basically, if I plot the curve for MR1 and MR2, okay, so MR1 looks like this, and MR2 is looking like this. And this intersection happens at Q1 equal to 7, which means that marginal revenue in first market is higher for the first 7 units. And after that, it is going to be higher in the second market. Okay, so the first 7 units should go in the first market. Okay, so if he's going to sell some entire quantity Q, then total quantity Q1 will be equal to capital Q, and Q2 will be equal to 0 if total quantity is less than equal to 7. And Q1 will be equal to 7, and Q2 will be equal to capital Q minus 7 if Q is greater than 7. So the first 7 units always go to first market because that is giving a higher marginal revenue. After the first 7 units, all the subsequent units will be sold in the second market because second market is giving you a constant marginal revenue of 10, whereas first market's marginal revenue is decreasing. Right? So the marginal revenue of first market is reduced. So I know that if he sells less than 7 units, so in total, everything will go to market 1. If he sells more than 7 units, 7 units will go to market 1. The remaining Q minus 7 will go to market 2. Okay. Now, final nail in the tooth is equal to marginal cost. Okay. So if you take this case, if total quantity is less than 7, let's say, marginal cost is Q. So what I'm saying is that Q1 plus Q2 must be equal to capital Q. So that's true if Q2 is 0. But the idea is that in this case, marginal revenue in market 1 is still higher. So what I'm saying is you want to equate marginal revenue. So marginal revenue in market 1 at Q equals to 7 becomes equals to marginal revenue in market 2, which is equal to 10. And if I equate it to Q1 plus Q2, what I get is Q1 plus Q2 must be equal to 10. So Q1 plus Q2 must be 10, which means that total quantity supplied is definitely greater than 7. Right? So this is my marginal cost function, right? Marginal cost is capital Q, which is Q1 plus Q2. So Q1 plus Q2 must be equal to 10, which basically gives me that Q1 must be equal to 7 and Q2 must be equal to 3. Okay, so Q1 7 and Q2 3. Fine.